Hello, Professor. My name is Ron Liu, who is a team member in Group H. Our group will give a general description to the process of completing the design project. This project involves the design of jetty by using the problem-based learning and group activities, a coastal structure at the Curimbing Creek at the southeast Queensland. Given a number of set criteria should be designed. The final design of the jetty was the result of our own research, learning outcomes, and personal motivations which we had learned in the course. Our group has 7 team members, so there are 7 parts in this presentation, and each member needs to present one part. The first section is my part, which is introduction of the study area. In this part, the construction side of the design project is introduced in detail. Then, second part is environmental condition. In this part, some characteristics such as wave direction, return period, tides, sea level rise, and storm surge can be determined according to some references. After that, hydrodynamic analysis should be considered. At the next part, wave height, wave period, and wave setup can be determined using some formula and EVA software. Then, the next part is wave transformation. In our report, shoaling, refraction, and breaking should be considered. The fifth part is constructor design. In this part, the reason of design is given, and some formula are used to define the lengths and the materials used in the design structure. After studying the structure, the cross-section of the structure is drawn, and the general expenditure can be calculated. Finally, the main points mentioned in this paper will be summarized. Curimbing Creek is located in southeast Queensland, which is near the Curimbing Beach. In the past, due to the narrow entrance, it always needs frequent maintenance work. Dragging works must be carried out frequently so that the depths and the entrance are at an appreciated level. The entrance of the stream is used by different stakeholders, both commercially and socially, so its maintenance and sustainability are very important. By designing and constructing a quay that does not allow sediment, movement, and deposition to reduce access, maintenance will be greatly reduced. At the same time, it will make residents and tourists a good place for entertainment. The proposed layout is shown in this figure. According to this figure, it can be found out that the jetty is proposed to be built in an offshore area with an initial water depth of 3 to 5 meters and a length of about 100 meters. This is my part. Thank you.
Hello, I am Muhammad Abdullah Ikram, and today I am going to present on the environmental conditions which impact the planning and design of the coastal structures. So in the environmental conditions, we have the wave characteristics, tides, wind setup, and SLR and storm surge, which is the sea level rise. We are going to talk about them one by one now. So the wave characteristics include the wave height, wave period, wavelength, and direction. Wave height is the, as you can see here in the figure, wave height is the vertical distance between a crust and its neighboring trough. So this is shown here. Wave period is the time taken for crust or trough to move at a point. Wavelength is the vertical distance between two consecutive troughs or two consecutive troughs, which is shown here in the by the green line. And direction of wave is the direction from which the waves are approaching or coastal structures. Now we are going to talk about tides. Tides is the rise and fall of sea level it's mainly due to the gravitational pull of the sun and the moon during the day. They are classified into different types, which include diurnal tides, semi-diurnal tides, and mixed tides. Diurnal tides have a period of one tidal day. That means that we will have one tide over the period of 25 hours. Semi-diurnal tides have a period of half tidal day, which means that we will see two tides during a day, and their period are of around about 12 and a half hours. And mixed have both diurnal and semi-diurnal tides in combination. So for the design of our structure, we found out that this is the figure which shows the tides on 6th May on our location. So this shows that we had two tides during the day, which means that we had semi-diurnal tides for our location, which we have to construct our coastal structure. And by using this data of semi-diurnal tides and estimating a design life of 50 years, we found out that the MHWS for our structure is going to be 1.47 meters. Next is the wind setup. Wind setup is the influence of wind on water level. This is the formula which is given. So by putting in all the values, we found out that the wind setup at our location where we have to make our coastal structure is 0.223 meters. SLR and storm surge is the increase in sea level. It is mainly due to the following reasons, which include thermal expansion of seas, because the climate change over the years is increasing the temperatures, which causes the water to expand. So we experience increase in the sea level. Also global warming also contributes to the increase in sea level and the melting of ice bodies like glaciers and ice caps, etc. So the SLR and storm surge from the CSIRO website, which had all the data for Gold Coast, we found out that the water level rise was 1.93 meters. Thank you.
Hello everyone, my name is Fan Zhang and I would like to introduce the wave transformation very briefly. At the beginning, we have learned that the waves will be transformed when they come from deep water and enter to shallow water. This transformation process includes shoaling, refraction, wave breaking, diffraction, and reflection. The first point, I would like to explain how we got the shoaling coefficient factor. Shoaling is the change of wave height because the decline of water depth. Normally, this results in increase of the wave height. Here is the equation of shoaling coefficient factor for regular waves, where K is the wave numbers and H is for the water depth. Therefore, we got two shoaling coefficient factors for proposed coastal structure at both head and trunk in our report. Secondly, I would like to introduce how we got the refraction coefficient factor. Refraction generally affects both wave direction and wave height. We assume the origin wave angle beta 0 is equal to 13 degrees based on the wave rose diagram, and the changed wave angle beta also can be calculated by using this equation. After that, we have known both origin wave angle and changed wave angle, so we can use the following equation to calculate the refraction coefficient for the head and trunk in the end. To organize what we got before, the final design wave height for the head is equal to 7.2 meters and 8.4 meters for the trunk. In the end, when waves propagate into shallow water, the celerity decreases while their height increases, and when the greatest particle becomes greater than the wave velocity, the wave becomes unstable and eventually breaks. In our report, we used the GODA 2000 method to calculate the significant wave height for both head and trunk. Furthermore, we also calculated a very number Kc to define wave breaking types as splitting in the end. Next part, my partner Sun Su will provide more details about the structure design, and thanks for your listening.
Hello, my name is Sun Su, and I'm going to talk about the fifth part, which is structural design. There are three small parts of this section which are regional for choose design, overtopping, and specific design. First of all, I'm going to talk about the reason why choosing the structure. According to the lecturers and other literature, there are many types of coastal structures such as this. According to the presentation from my other team members, it can be determined that the original purpose of the design was to build a jetty. However, build a normal jetty does not effectively reduce the impact of waves, sea level, and other conditions. Therefore, a breakwater should be built on the jetty to resist these factors. Then, I'm going to talk about overtopping. Overtopping is a part of hydrologic design. Overtopping discharge mainly depends on the function of the structure and the weight. It can define the crest height, so it should be considered in our project. Finally, I'm going to talk about the specific geometric and structural design. According to the figure, it can be found that there are two sections of this typical breakwater structure, which are head and trunk. For trunk design, according to the difference of permeability, the structure can be designed into four different types. In project, P equals to 0.4 are chosen for the structure. The figure on the top shows this structure. The first step is to determine the equivalent curve length of medial rock. Rother-Meyer formula is used to determine DA15. First is to determine zeta m and zeta mc. Zeta m can be calculated using mean wave chariot. Then comparing them to calculate the other unknowns in the equation. Then the calculation of height structure is different. These two formulas are used two major equations. Some of the unknown can be determined using following table. After completing the calculation of DN15, the following steps are similar with trunk design.
Hello everyone, my name is Gaoming Rui. Now let me talk about part 6, section joints and cost. In this design, we have two sections, the trunk section and the head section. For the trunk section, the length is 70 meters, the crest is 7 meters, and the average height of the trunk is 18.2 meters, according to RC and design height of Waterloo. As it is a 3-layers trunk, the layer thickness equal to 2 times DN50 of each layer. As for the core and toe slope, is 1 to 1.5. There are 2 toes in each side of the trunk section, and each toe has total 3.75 meters length with 2 segments, which heights are 1.5 meter and 3 meters. As for the head section, the average height of head section is 19.2 meters, and the crest is 4 times larger than the crest of trunk section, which equals to 28 meters. So we can assume the head section's diameter as 30 meters. However, the primary MO layer is different with the trunk section. Since we are unable to obtain a 20-ton stone, so we use dollars instead of MO stones. As for the core layer, we calculate it as 0.4 meters. However, it at least 0.5 meters to use. As for the core and toe slope, it's similar with the trunk section. As for the cost design, this is one of the most significant parts in the whole design. So, we calculated the volume of core and layer respectively. Since the unit price of stone and sand are different with a different unit weight, so we need to multiply the unit price by the volume of stones with different unit weight. Since the cost function of stones can be calculated as the total cost equals to 14.8 multiplied by average unit weight of stones 0.17 square. Thank you.
Oh, this is Tian Shuo. Let me talk about the part of bypassing estimation, recommendation, and conclusion. First, the bypassing estimation. The bypassing is an upstream set of the terminal which is filled due to the longshore sediment transport. And the calculation formula is shown as below. And then we use this table and figure to determine the depth of course is HC, and according to the study area of the project, assuming all the parameters shown as below. And the result is about 1/2 year. Next part, for recommendation and conclusion. For recommendation, first, the conditional limitation. This task only analyzed and calculated the data and did not observe it on site, so the result have certain limitations. Second, the construction safety issues. According to the observation of the data of the past 10 years, it can be found that the wave height of the sea wave will change differently in different years. For construction safety, it needs to pay attention to the construction environment on site. Third, the budget spending problem. Because this project was done for the first time, so the cost was not considered in the design. So saving the budget is an aspect that needs attention. For conclusion, in this assessment of jetty design, the source of the wave height data is a EVA analysis software, which has been used for 10 years of data analysis. According to the geography analysis of the Carobin Creek, the structure is divided into the 3 layers to reduce the sediment, which are primary cover, first layer, and core layer. And the complete structure can meet the safety requirements of the task. That's all.